Today we're going to talk about inscribed angles. Inscribed angles means that the vertex will fall on the circle, okay, so on the edge. So if we look at the example on the right-hand side, our inscribed angle would be right here, BAC. Now remember, you can call this angle BAC or you can call it angle CAB, but don't you dare call it CBA or call it ACB, because that's not the angle. The intercepted arc is the arc that the angle eats. So if you imagine this is like a mouth with teeth, there we go, it's eating this arc right here, right? So it's going to eat this right here. So this arc right here would be BC, that's its intercepted arc. So we're going to talk about some formulas that we can use whenever we talk about inscribed angles. So the measure of an inscribed angle is half the measure of the intercepted arc. So let's go ahead and talk about this formula in reference to this picture. So our inscribed angle is angle ABC, okay? And that inscribed angle, which means the vertex falls on the circle, is going to be half of the arc. Now the arc that that mouth is eating is AC, so it's going to be half of that arc. So let's go ahead and apply that to some problems down here at the bottom. So for the first one, it says find each measure. So first thing, I see that it is an inscribed angle. So the inscribed angle equals half of its intercepted arc. So my inscribed angle here is BMW, angle BMW, and that's going to be half of its intercepted arc. So that mouth there is eating BW, arc BW. Well, angle BMW is 62 degrees, and that's going to equal half of the arc, which is BW. Well, we don't know what arc BW is, and that's what they wanted us to find, right? So what I do to both sides here is I divide by 0.5, and when I do that, I get 124 equals BW, the arc, the measure of the arc. Okay? I'm going to skip 2. I would like you to do that for class. So when you come to class, go ahead and bring number 2 with you and have that all done. But I definitely want to talk about 3. Now don't be too scared of 3, okay? We want to find FB. So I'm going to go ahead and highlight FB just so I know later on, oh, okay, that's what we have to find. And let's look at what's going on here. So a couple of things. I do see this inscribed angle right here. So let's focus on this inscribed angle first. So remember that an inscribed angle is going to be half of its intercepted arc. So the inscribed angle here is FBA. That would be the angle that's sitting on the circle. The vertex is on the circle. And that's half of the arc. And our arc that is eating is FA. Well, we know that FBA, looking at the picture, is 83 degrees, so we'll substitute that in. So 83 equals 0.5 times FA, and then to get arc FA alone, we divide both sides by 0.5. So we'll get 166 equals arc FA. All right, so I'm going to label this right here, 166. Well, that's not really helping me, right? Because I need to find FB. So let's see, what else can I do in this picture? Well, I'm seeing this. I see one more inscribed angle right here. Okay? So that inscribed angle, now I'm going to take my blue and show you. That's the 166, right? Right here with the blue. This red, though, look how much it grabs. It goes from here all the way through and around. Do you see how the red goes all the way through and around? So we're still going to use inscribed angle, but this one is BLA, and that equals half of its arc. Well, the red arc here starts here, and that mouth eats all of this. Look at that mouth. Chomp. So it goes from B to A, the whole thing. So we know that angle BLA is 130 degrees, and that equals half of arc BA. Well, if we divide both sides by 0.5, we get 260 degrees equals arc BA. So we know that this whole red area right here is 260, but we want to find the yellow. Well, let's think about this. If the whole red part is 260 and we only want the yellow, then we need to chop off this blue part, right? If this whole part here is 260 in red and I only want yellow, I need to chop off this blue part. So essentially what you're doing, FB is going to be the whole red part, which is 260 degrees. But then what we're going to do is we're going to subtract off the blue part, which is 166 degrees. So then arc FB ends up being 94 degrees when we work this out on the calculator. Okay? So that one's definitely a little trickier. It has 2 of them in it, and you also have to use some subtraction too. All right, let's keep going. On the next page, it says find each measure. So let's look at number 4. On number 4, we have this big old mouth right here. Now, notice what it's eating. It's eating this, right? This is the whole thing that it's eating. How would you describe that? Isn't that half the circle? Well, what's half of a circle? 180 degrees. So this is going to be 180 degrees right here. So the intercepted arc, because the vertex is on the circle, is half of the arc it eats. So in other words, x is going to be half of 180 degrees. So then if you work that out in the calculator, x must be 90 degrees then. Okay, well let's look at number 5. Not a lot we can do here to find x because I don't know this arc, so I don't know the angle and I don't know this arc, right? But let's see what we can do inside here. Well, can I find out what this is? I'm just going to call this y since we don't know what it is. And check out what y is doing. This is a mouth. What is it eating? How many degrees is this? Do you notice that it's half of a circle? So it's 180 degrees. So again, the intercepted angle here is going to be half of the arc that it eats. Our angle here is going to be y, and that's half of the arc, which is 180. And then if you work out 0.5 times 180 on the calculator, you'll get y is 90 degrees. So let's talk about this. In a triangle, how many degrees do all 3 angles add up to be? Well, all 3 angles should add up to 180. So then x plus y, which is 90, plus 32 should equal 180 degrees. So if you subtract 90 and you should subtract 32 from both sides, you'll get x is 58 degrees. So not only did you have to use your inscribed angle in number 5, you also had to go back and think about how many degrees are in a triangle, which is some prior knowledge from earlier in our class. I'm going to have you try out number 6 and bring that one to class. So try number 6, bring it to class, and we'll discuss it when you come in. Don't forget, if I'm going too fast, you can pause the video or you can rewind and rewatch. It's totally up to you. Okay, let's move down here. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Do you remember what supplementary means? 180 degrees, right? That means 180 degrees. And opposite angles means straight across from each other. So let's look at this example right here. Angle D. What angle is opposite from D? Now you're running away from D to the other side. Don't go this way. This is not opposite from D. This is right next to it. And E is right next to D. So if you run away from D, your opposite angle here is L. So angle D plus angle L are supplementary, which is 180. What about angle Z? What's opposite from angle Z? Go straight across, and you get angle E. Okay, so opposite angles are supplementary when we have a quadrilateral, a 4-sided shape, inscribed, that means inside, a circle. So let's look at number 7. Knowing this information then, let's go ahead and write out what our opposite angles are. So 72 is opposite from y. So 72 plus y equals 180 degrees. And if I subtract 72 from both sides, I'll get that y is 108. Let's look at the x. X is across from 44. So x plus 44 equals 180 degrees. If I subtract 44 from both sides, I get that x equals 136 degrees. Just like that. Let's look at number 8. What's different about number 8 than number 7? Well, let's talk about these two guys. What does this symbol mean? 90 degrees, right? That means 90 degrees. So we know that 90 plus x, opposite angles, equals 180. Then we would subtract 90 from both sides, and we'll get x equals 90 degrees. Let's take care of y. These are across from each other. They're opposites. So y plus 119 degrees equals 180. We would subtract 119 from both sides, and we'll get that y equals 61 degrees. All right, so I'm going to have you try number 9 and bring that into class. Number 9 should be pretty easy. It should be very similar to number 7. All right, see you in class. Have a great one.